Okay, guys, so let's get started with today's session, right? So I'm really excited. Now, in today's session, we are going to learn something about NumPy, right? So NumPy, or some people call it NumPy, right? Thank you, Krish. So so we're going to play with this course, this NumPy crash course. So in today's session, I'm just discussing the agenda here, guys. So I'm going to give you the overview of NumPy. I'm going to discuss something called arrays. Arrays are the backbone of NumPy, right? So in this today's session, we're going to play with arrays, right? So there's nothing which is conceptual, or there's no concept kind of thing here. So it's all about arrays here, right? So array, what is array and how we're going to use it? So you're going to see it in my coming demonstrations. Then we are going to work on array manipulations, and then some advanced array manipulations, and a lot of exercises that we are going to do today, right? So this is something which is planned for today's session. Now, everyone, right? So today we are going to start with NumPy, right? No, Piyush, I'm not going to use any CSV file, right? So I've kept this session limited to the programming part. I'm not going to extend this part, so that my participants can focus on NumPy only today. So that's what I've planned. Even I'm not going to go into OOP part as well, right? So as I did in the last session. So today we'll be sticking to NumPy only. That's what I've planned, and that's how I've planned, because NumPy is something which requires you to to dig into this thing, right? So it is not like okay, you have done it once and then you can simply proceed further. No, it is going to take some time to take over this part. Okay. So first of all, yeah, thank you, Piyush. So first of all, we are talking about the NumPy here, right? So I'm just going to tell you exactly about the NumPy part first of all, and then we are having lots of demonstrations today, lots of demonstrations today, right? And there's going to be many inputs and outputs in today's programming. Now, uh, can I ask my participants how many of you are doing the practicals parallelly, so that I can just make the speed with you, right? Or you can make the speed with me. So I'll just uh, do like that. Okay. Okay. So there's a good team that is working on the parallel practicals. So fine. That's great. Thank you, Chena. Chena, that's good. Okay. Thank you, Sai Ganesh, Pavitra. Okay, fine. That's great. So, I encourage you to type little fast, right? And make sure that you don't confuse or you don't miss the content while typing, right? So just stay with me, and I'll be with you, right? Okay, let's get started. So here we're talking about NumPy, right? So basically, first of all, what is NumPy basically, right? So NumPy is the most basic and powerful, module of Python, which basically allows you to work with data. Now, first of all, you need to establish some connection with data in NumPy, right? So if you're starting with the NumPy for the first time, you need to have data in your mind, right? So basically, I'll give an example, right? NumPy is not used in basic programming, right? Just understand this thing. We don't use NumPy in basic programming. So here we're talking about something which is your future. So let's take an example. Let's say we have a data, right? So let's say if we have a shopping data, or if we have a tabular data, if we have some records, rows and columns, right? So how are you going to represent those millions of rows and columns in programming sense? So for that, you need something called a multi-dimensional array, or a 2D array, right? So that array kind of concept is the backbone or the key of NumPy. So here I'm going to say three words here: NumPy, array, and data. So what is the connection between these three words: NumPy, array, and data? So NumPy provides you array that can store data. So, and that array is basically special because NumPy provides you hundreds of built-in functions, hundreds of built-in properties that can easily manipulate that data according to your requirement. So in today's session, in today's session, you're going to see that how we create arrays with NumPy, and how we can manipulate that array in various senses, right? In various ways. So that's how it is going to work. Now, Okay, fine. One more note to all of you. NumPy is not going to make sense in today's session much. You know why? Because NumPy makes sense when the library or the array of NumPy is used in the data analytics further, and used in the machine learning further. So NumPy makes sense mostly when we have data analytics, when we have NumPy all together. In that case, NumPy makes more sense to us, right? So in today's session, it is a array play. I'll say like that. It is an array play. So you're going to learn how to play with array and how you can, simply juggle around, this array kind of concept. So once again, I would like to give you a simple conclusion here. There are three things that you need to take care of. One is NumPy, array, data. The data is stored and represented in the form of array, and this array is provided by NumPy. Now, here is a question. Here is a question. We can represent the data in the form of Python list as well, in the form of Python dictionaries as well, in the form of Python tuples as well, right? So why we are talking about NumPy arrays? That is the question here, right? Okay, now listen to me carefully. Now, first of all, the traditional data structures, the traditional data structures that we are talking about from the Python part is the tuples. We have lists, we have sets, we have dictionaries, but these data types, these data structures from Python have a bad side of them, right? Yeah, have a bad side to them, have a curse associated with them. And I'm going to tell you exactly what curse is there, which is associated with the Python data structures, with the standard Python data structures that we are talking about here. And that curse is the hunger of eating the memory. There are two curses I'm talking about here. The first curse that is associated with the basic Python data structures is the hunger to eat memory. So when you're using list, when you're using tuples, dictionaries, or sets, even the normal integers, they eat memory. They take a huge chunk of memory for the small data, or for the smallest block of data. They eat more than that. That is the first thing. So the first point is they are hungry about memory, right? The RAM part. Now, the second part is the performance. They are very slow, right? So I'm going to show you a demonstration for this. So the standard Python data types are slow. They perform very slow when you're doing large computations. Yeah. So when you're doing computation on matrices, right? So when you are multiplying matrices, when you are, iterating through matrices, when you're doing traverse lower matrices kind of thing. So, they are comparatively slow. So all these curses of basic Python data structures are actually reversed in positive way. So when we talk about the array which is provided under the NumPy tree, so this array has got everything which is not there in Python data structures, and I'll say only two words here. One, memory efficiency. One, memory efficiency, right? NumPy, the arrays under the NumPy tree eat a lot less memory compared to what a list or a tuple requires in their cases. So the very first thing is that NumPy arrays eat a very less memory, right? Now the second point is that NumPy arrays are super fast. They perform excellent, right? They perform excellent in terms of performance, right? So if you're talking about the latency part here, it has got a very high latency. Means it's super performing, right? You simply get the response in milliseconds, right? So whereas the same computation, the same programming takes seconds, or even more than that in Python data structures. Okay. Now the question is that, now the question once again, right? Once again, I asked, when I was learning NumPy years back, so I asked my trainer that why so NumPy is faster compared to basic Python. So the answer is that the faculty, the trainer told me that, at that time, that the NumPy is built on top of C. right? So NumPy is written in C programming language along with some basic Python as well. So most part of NumPy is written in C, and that's why NumPy performs faster than Python. So this is the reason why NumPy is NumPy data structure. So the only thing that we're going to pull from NumPy is that we're going to pull the data structure only. We're going to pull the arrays only, right? So from NumPy, we're not going to pull the OOP concepts. From NumPy, we're not going to pull the file handling concepts. From NumPy, we're not going to pull, the exception handling concepts. No, we are going to pull the data structure only. And once again, I would like to give you the conclusion here. Why we are pulling the data structure, the array part from NumPy? Because of only two things. And the first thing is, once again, the memory efficiency. And the second is that the performance, right? Memory efficiency and performance. Only these are the two reasons why we use the data structure, the array part from NumPy. Okay. So guys, I would like to ask you, right? Is the fundamental of NumPy is clear to you, right? Did I make you clear exactly what we are talking about here, NumPy? The point is that you need to understand why we need to use NumPy, right? And things like that. Yes, Optic, it provides a ND array, right? So n-dimensional array. Thank you, Bindi Santa. Thank you, Bhavya. Thank you, Pavitra. It's a library, Ashutosh. It's a library. It's a library. Okay, fine. Thank you. Okay. Eligeni, why it is fast, it's not clear. So he says. So basically, thank you, Divanjan. It is fast because it is written in C, right? So C is generally faster by its nature. So that's why it is fast. Once again, Jeffrey, it uses stack, right? Okay. So the NumPy key, right? The last line here is that what is the key to NumPy requirement or NumPy performance or memory efficiency? And the answer is n-dimensional arrays, right? Okay. So this is just this is just a summary of exactly what I've discussed here with some extended information here. So it says like NumPy is an open source library available in Python that aids in mathematical computation, whether you are doing scientific computation, whether you're doing engineering calculations, or you're doing data science programming. So as I told you in the beginning, right? When you're doing core NumPy, it doesn't make much sense, right? So when you're doing the fundamentals of NumPy, but when you're doing the computations at a higher level with bigger challenges, and in those cases, when you see the memory efficiency, when you see the performance efficiency, in those sections, you find the sense to NumPy, right? So in today's session, I'm going to tell you what arrays are and how you can play with the arrays. And further in my next session, I'm going to show you exactly how NumPy arrays are used, right? Okay. So NumPy is basically an incredible library to perform mathematical and statistical operations. As I told you earlier, it works perfectly well for multidimensional arrays and matrices multiplication. So it is like it's a lot of mathematics involved here. So in today's session also we're going to discuss some of the mathematics here. So let's get started. This is the last slide, right? So as I do in most of my sessions, that I keep the content on the lower side. So this is something that I want to tell you: n-dimensional array or ND array, right? So when we're talking about performance, when we're talking about memory efficiency, who is the hero here? Who is the who is the reason here? Who is the strong part here for bringing all these features through NumPy? And that is called ND array, right? It's all the n-dimensional array. So we're going to work on this ND array, right? And it is a powerful n-dimensional array object, and it has advanced array slicing methods. So I hope you remember the slicing Walla part, right? I think we did it in strings, right? We did it in list as well. In list, I told you to repeat actually. Okay, fine. Thank you, Vani. Thank you, Sai. And I'm going to tell you something about reshaping, exactly what exactly reshaping is, right? So there is a lot of things that I'm going to cover today, and just be with me, right? And the most important part before starting the practical, right? The most important part before starting practical is that you need to think in the same way as I am thinking. You need to grab the question first of all. You need to, grab the question, and then you need to understand the logic, and you need to see the output and compare the logic with the output. So it's going to be, 2-3 stage process that we're going to work with, because in today's session we're going to play with a lot of numbers, right? So a lot of numbers we're going to play with. So you need to be careful, right? What we are talking about here. Don't lose the connection. Don't lose the connection, right? Don't lose the connection first. That's a note. Okay. So I'm going to launch the Jupyter part here. And now I'm going to click on Python 3. Here's the beautiful Jupyter. NumPy in action. So here we have NumPy, and so Rajesh, according to your question, the remaining 4 sessions you can see probably in your upGrad portal, in case if the videos are not available there. So I request you to drop a mail to the upGrad care team, and they're good at replying and resolving the issues. I'm very much sure. All right, thank you, Rajesh. Fine. So here we're starting with the NumPy in action. And first of all, what we're going to do in order to use the NumPy library, basically, we need to import the module, right? Import NumPy. So this import is a keyword in Python, which is to include a library, and the library that I'm including here is import NumPy. The best part is that we are using Anaconda distribution, and in Anaconda distribution, basically you get the popular libraries are already installed, and this is how we include the module, right? And further I'm going to call some good functions, right, for doing the computations. So repeating, so this will be the syntax for calling the functions, right? So I'm going to call some functions from this library, and for every function calling, I need to use the reference of the module, so and that is NumPy. But what I'm going to do is I'm going to create an alias here as NP. So basically, this alias helps me in reducing the typing, right, the keystrokes. So further, when I'm going to use the function from the NumPy library, instead of writing the whole NumPy, I can simply write NP here. So I think this alias makes sense now, right? So I hope everybody is clear with the alias part. Okay, thank you, Reshma. Okay, that's great. That's great. So that's how we start, guys. Import NumPy as NP. NP is an alias for NumPy. And here, what I'm going to do is I'm going to create a an array here, right? An array, right? So what I'm going to do is my Python list equals to 1, 2, 3, and 4. So here what I've done, I've created a list, and you can easily see that this list belongs to Python. And for easy understanding of exactly what we are doing, I've just named the variable according to the context here, right? So that is my Python list. And what I'm going to do is I'm going to let's convert list, my Python list into NumPy array, right? So I'm going to convert that list into NumPy array for getting the maximum performance out of it. So Saurabh, okay, just a second, guys. Saurabh, you got an import error, right? Saurabh, can I ask you, like, are you using Anaconda or the plain standard Python? Anaconda. You must not get import. In case if you're using Anaconda, okay, Sai Ganesh, for you, go to the kernel menu and click on restart. That is your thing. Saurabh, NumPy in action import. Saurabh, this should not be there. I think every anaconda has this NumPy. Yeah, Salai. That's not required, Salai, as of now, but NumPy should be there. Roshan, you're getting NumPy error? Okay. So can we do one thing, right? Let's go to environments, and I'll simply, click here, open terminal, conda install NumPy. Let's see if this works, right? Okay, fine. I'm happy to see that for you it is working. But Saurabh, I'm really unsure about why you're getting that error. So I think you can follow the same command here as I'm doing for for installing the pandas. Thank you. I'll just move back, right? So here, what I'm going to do is I'm going to convert that list, my Python list, and I'm going to store in this variable NumPy array. Print NumPy underscore array. Okay. Print type NumPy underscore array. So here, guys, this is how it works, right? So it's just a basic start that I'm giving to all of you. Make sure that you're not slow and lazy right now, because it is going to be a very tricky programming further. So Shruti says, Shruti, please post the questions to attendees as well, right? So Shruti has a question. What she says that what is the use of converting list to array? So the use of converting a list to the array is that now when you convert a list into array, the very first thing is that it is going to occupy less memory. Second, whatever further computations you're going to perform on array will be faster compared to the Python list. Thank you, Sarah. Okay, thank you, Shruti. Fine. So once again, you need to remember two things in the background: memory efficiency. I'm going to show you the proof for this, right? I'm going to show you the proof for this. Don't worry. And performance, right? Yes, Shagun, that's true. Because Shagun, the reason to your question is because it is an object. That's why, not a kind of structure. Okay, so here you can see that I told you that the key or the backbone of NumPy arrays is the ND array. You can see the ND array here, right? So this is what I was talking about. Now we will not call it as array. It is a ND array, right? So it goes like that. Now I'm going to show you some more demonstration. So the next 10 minutes are going to be easy, right? And further, it is going to be tricky. So just make sure you go with that. Okay. Anthony Boyti, please post your questions in to the attendees as well so that they can see. So Anthony Boyti says, Anthony says you're getting the name error. So make sure you are doing the same exactly as I'm doing. Yeah, Vani, we can do that according to you. Salai, it's not a limitation because generally when you're doing, let's say, machine learning or data analytics using NumPy and other libraries, you're working on a fixed data, isn't it? Because we're not working on a variable data, variable records. So the data is archived and fixed. Okay. Let's proceed further. I'm going to show you some more basic demonstrations on NumPy. So here we have arrays, various data types. Thank you, Roshan, for that. Thank you very much for informing. That really helps. So arrays of various data types that I'm going to talk about here. So here x equals to np dot array, and here I'm going to take 1, 2, 3, 4. And if I print x here, so it prints 1, 2, 3, 4. And if I print the data type, right? So if I print the data type of that array, it is int 32, right? So data type is a property here which is used to print print the data type of that particular array, and that's how we go it like that. Okay, fine. So further moving to the other thing, other demo, x or y equals to np.array, and here we have 1.0 comma 2.0 comma 3.0, and if I print y, we'll see the output of that y, and here I'm going to print the data type of y. So I'm doing some simple things here, just making you comfortable in the first 3 or 4 or 5 minutes, and then further we're going to jump on some bigger things, right? So just getting you familiar, right? Spending some goody times with these arrays. Okay, Suren, you can have different data types as well, right? So that's not an issue. Okay, x, y, z equals to np.array, and this time I'm going to mention 1 comma 2 comma 3 type equals to np.int64. Okay, print z dot d type. Okay, so d type is a property, guys, we used to know the data type of the given array. So here you can see that in the first example we saw that it is int32, and then in the second example we have float 64, and in the next demonstration we have a medium, a mechanism to specify what data type we want, right? So this is how we do that. So this is how it is going to be done, right? So just giving some time, just giving us a pause of 15 to 30 seconds so that I can help Saurav, Kamal. Saurav, you said that updation was done. I closed the command prompt. So you do one thing. You simply Google online compiler for Python and just start programming on that thing, right? So that will be helpful in today's session. Okay, fine. Okay. Soptik, you have a question there. What is the difference between int32 and int64? The difference is of the difference is of two things. One is the memory occupancy. So int32 is going to occupy 4 bytes, whereas int64 is going to occupy 8 bytes. That's the first difference. Second difference is of capacity. So int32 can accommodate bigger numbers, and int64 can accommodate more than bigger numbers or the large numbers, right? So it's like that. The capacity is different. So here in this Z wala part, right? So in this section, basically, I just explain you exactly in case if you want to specify data type, right? It's supposed to be int32 first of all, right? But let's say for some reason you want the data type of this array to be int64. So instead of int32, so that's why you can that's how you can specify the data type. It's like that. No, Reshma, D-type is not for listing of properties and methods. D-type is for data type, right? It's for knowing the data type or for specifying the data type. So you can use in both the ways. Okay, fine. So I hope everybody is getting along with NumPy, right? Once again, I would like to tell you that one thing I would like to tell you that the main reason why we are using the arrays from NumPy is for performances, and there are 3 reasons I will say, right? I will say 3 reasons. One, memory efficiency. 2, performance. And 3, huge sets of functions for array manipulation. So I'm going to discuss this thing also. No, Shivani, data cannot be used with the normal Python programs. Yeah, Jeffrey, it can have. Okay. Asim, when you have less than U11 something data type, and that is for string representation, right? It's for Unicode kind of thing. Rohit, multidimensional arrays are possible in Python. That's always there. Okay. Okay, everyone. Now just sit back, relax, and now I'm going to show you how NumPy is memory efficient, right? So how NumPy is memory efficient, right? So I'm going to show you a demonstration here. And in that demonstration, I'm going to show you exactly how NumPy can be a memory efficient thing. And Ravina, as per your question, by all the arrays that I've created till now are one dimensional only. They're not 2D arrays. I'll show you how to create 2D arrays. Okay, I'm sorry for that. So, I'm going to, tell you exactly how NumPy is memory efficient. This explanation will give you a strong foundation exactly why you need to learn NumPy, why you cannot exclude NumPy. Do you know that NumPy is mandatory for, all the data science programs? You cannot skip it. So let's see a demonstration where we'll find that how NumPy is memory efficient. And for that, I'm going to introduce one more module here, and that is something called time. Right, time is one of the module which deals with the time, time related activities, time, day, hours, minutes, isn't it, like that? And it has a function called ticks, right? That I'm going to use in my further demonstrations. So just giving you, a hint here of overview that there is a module called time that I'm going to use in my further demonstrations, right? On in this demonstration also. So how NumPy is memory efficient? So what we are going to do is we are going to, okay, let me tell you the plan. We are going to create a list and a list in Python and an array in NumPy of size 1000. You got this, guys? So what we're going to do is we're going to create a list of in Python and array in NumPy of size 1000 elements, and we are going to check the total memory occupancy of each list and array. So that's how we'll come to know that exactly, you know, exactly what size they're occupying, and if there is a huge difference, it will give us a strong reason to, to go with the NumPy part. So here it goes like this. Import sys. This is once again one more module in Python, right? And why we are using sys, I'll tell you, because sys has a function called sys.getSizeOf. So sys has a function called getSizeOf, which returns the size, in bytes. So whatever value you pass, let's say I pass an integer here. Let's say I pass integer 1. So it's an integer, right? So what it is going to do, it is going to, give me the size of integer, not the 1. Sys is system, that's true. So you can see here that how much size, how much memory, sorry, integer occupies in Python. And here you can see that it occupies 28 bytes. Sorry, that's huge. All right, guys, so I'm back. Just had a trouble with the network connections. Okay, so that is a get size of, and let's proceed further. So we have something called Python list, and here I'm going to use a function called range, and I'm passing the value 100. When I says you got 14, right? That depends on maybe the difference in the Python version probably, and the operating system also. In case if you're using a different operating system or a different Python version, there are chances of differences, right? Because in different operating systems, the memory occupancy is different. And I'm using 64-bit. Okay. No, Palak, it's get size off. Okay. Arrays are homogeneous, right, Nivas? Okay, so let me complete the demonstration here, right? So that I can show you the things here. So here I'm generating numbers. So range function generates numbers from 0 to n minus 1. So it is going to generate uh, numbers, right? I'm just showing you, right? So okay, it shows like that, but believe me, it has numbers within it. I can iterate through that. Now, in the next demonstration, what I'm going to do is I'm going to generate a NumPy array of the same size, NumPy array, and here I'm going to generate you know, 1,000, right? So NumPy has a function called arange, does the same work as range in Python, right? So here you can see that I'm using I've created two lists here. One is the Python list and second is a NumPy array. Now here, for generating the NumPy array, I'm using the arange function from the NumPy library, and the size is the same. The size is 100, so it's also 100 elements. And so what I'm saying, it's 1,000, right? So it is 1,000 elements in the Python and 1,000 elements in the array. Now, what I'm going to do is printing. Okay, the total size occupied by Python list is comma. So we have Python underscore list, right? The total number of elements in Python list into sys.get size of a number, because all the numbers are integers in Python. So here, okay, let me explain this thing, right? Shagun, both are same. KD, you are using double R. It's single R in arange. Okay, sorry for the interruption. Okay, so here I'm retrieving the number of elements in the list. Okay, so len is for number of elements in a list into the size of one integer. Okay, number of integers in a list into size of one integer. That's how it is going to do. Okay. Okay. Print. Coming to the questions, right? Just give me a moment. The total size of the total size of NumPy array, right? So for this, what I'm going to do is NumPy array, an array dot size into NumPy underscore array dot item size, like that. Okay, so that's how it goes like. So here we have a function, okay, property, right? It's getting complex, I know, but just be with me, right? NumPy array dot size, it returns equivalent to len, okay? It returns equivalent to len into item size. Item size is okay, fine. Okay, fine. NumPy underscore array dot size returns number of elements in array. This will be better, right? If I write it here, NumPy underscore array dot item size returns size occupied by one element in NumPy array. Okay, like that. So in case if you want to print these values differently or separately, you can do that, right? I'm just trying to show you exactly what the output is and how it is working. Oops, where is the error? Okay, I forgot one. Okay, just give me a moment, guys. Okay. Okay, fine. So here is the difference, guys. The total size occupied by Python list is 28,000 bytes, whereas the total size of NumPy array is 4,000 bytes. So you can see the difference here. It's huge difference, and the difference is such huge that it is, many times manifold, right? It's manifold what it is actually is. So we have the same number of elements, 1000 and 1000. So if we do the same thing in Python, so it is 20,000 bytes, and if you do use the same thing in NumPy, it is 4,000. So it's such a huge memory saving, isn't it? So that's too much. Okay, so coming back to the questions here, guys. So I have a lot of questions which are going in the chatting window. So guys, in case, okay, fine. So here's a small formula for all of you. In case if you are finding different sizes in your systems, that's completely okay. That depends on what kind of operating system, what kind of Python version you're using. So whether it is a 32-bit OS, 64-bit OS, Python, which version, right? So there are a lot of factors which affects all these things. So, and that's okay. For the time being, I would like to encourage you to see the difference, right? And no matter what numbers you're getting, but the size of the general Python must be at the higher side. That's what I'm trying to show here, right? Okay, now what I'm going to do is I'm going to show you another demonstration that is going to be a little more tricky, and it is going to take some more concentration, right, from my participants. So here in this demonstration, I'm going to show you exactly performance, right? Performance vector in NumPy, right? So this is something that we're going to talk. Performance is something, which is always been the number one priority when compared to space occupancy. So we already have learned in data structures that we give priority to performance, the time, complexity compared to the space complexity. So this is what it is all about here. So in this demonstration, I'll just show you the plot. Exactly what I'm going to do here is, so in order to show you the performance factor, I'm going to show you the output in the milliseconds sense, right? So what is this output in the millisecond sense? So let me tell you the whole plot here. So I'm going to create two Python list and two NumPy arrays, right? So I'm going to create two lists, which is like L1 and L2 in Python, and N1 and N2 in arrays, and I'm going to I'm going to see the difference in time or time comparison, right? And we will compare exactly how much time did it took to add, exactly, right? I'm saying different time comparison while adding, right? While adding the two list, right? So I'm going to see the difference in time, right? It's a time comparison while adding the two list. So I'm going to add the two Python list, and I'll check the time consumed in adding the two Python, and then I'm going to check the time consumed in adding the two NumPy arrays. Uh, Hi, Josh. That's good, but it is going to make the program complex here. So I'm just keeping it simple and letting the same thing on you, so that after I'm done with the basics, you can extend that, and or else I can do it offline and send it to you. Thank you. Hi, Josh. Fine. I'm very much sure that he's happy. Okay. Fine. Let's get started. Import time, as I told you earlier, right? So that's why I discussed this thing. Import time is one of the module that deals with the time part, and time module has a function called time, right? What it does, it returns something called ticks or seconds, right? So this is like that. So here there's a function called time.time, right? So what I'm going to do is I'm going to use this function, and returns the number. What is this number? This number is actually a seconds, right? So basically it's basically like from 1st Jan 1970, how many seconds have elapsed. So it's like that, right? Sounds yeah, epoch. That's true, Shruti. So okay, you remember all these things, right? That's good. That's good. Okay. So this is seconds, right? So I'm just going to use these seconds. And I'm just going to show you the some basic thing here, right? Start and end, right? So basically, end minus start. So that's how we see the difference, right? So that's how we see the difference. Basically, like how much time has crossed, and there was no difference in the time. So I'm going to make some difference here, like 0.2. Okay, fine. So you can see here. So it's a delay of 200 millisecond. So there's a function called type, right? I'm not confusing you, right? I'm not confusing you. So I just wanted to show you that when you compare the computation, you get the response in less than 1 second, right? So you get this kind of value. So what I'm trying to say here is that in order to show you the difference in the milliseconds, I'm going to multiply the number by 1,000 so that you have a precise idea about how many milliseconds have passed by. So the output is going to be in milliseconds. I'm just preparing you for this magic or this math here, right? So in 1 second there are 1,000 milliseconds. So this is something which is there, right? So 1,000 milliseconds is something is the unit for 1 second. So because the difference is going to be very, very less, it's going to be some 0.00 something. So if I want to tell you exactly how much, like, because we cannot understand 0.00, isn't it? So that time is something that it's difficult for us to imagine or visualize. So what I'm going to do is I'm going to convert the difference of 0 point something 002 something 3 in by multiplying it into 1,000. So that gives us the time in milliseconds. So that's how it is going to work, right? So guys, is this concept clear to all of you, right? So I was just preparing, right? I've not started my demonstration. Okay. Okay, that's great. That's great. Okay, fine. So here, let's get started. So this is list one, and in list one, I'm going to prepare. Okay. It is difficult for me to count, isn't it? Okay, it's 10 lakh. I got it. Okay, so this is how it is going to work, right? So I've created a list of numbers, right? I'll do this because I'm going to use it. Okay, now this makes more sense. So I have two lists here, right? And can I ask, this list belongs to Python or NumPy? Okay, Python, that's true, because obviously that's true. And here, A1, we have np.arange, and we have the same size, and we have A2 here, np.arange, and here we have the same size. So guys, as I told you that we are going to create two lists here. One pair is for Python, and one pair is for NumPy. What I'm going to do is I'm going to add both the list, and we're going to calculate the time difference here, right? So let's do this. So first of all, let's do this for the Python part, right? So what I'm going to do is start time, right? Started the meter, right? Or the count, the time tracking, right? Started the time tracking. Now in the further code, what I'm going to do is result equals to okay, for x comma y and zip L1 comma L2. Okay guys, it's a beautiful expression here, right? So what this for loop is doing, basically, I'm using a built-in function called zip. What zip function does, it extracts one item from L1, one item from L2. It stores that one item in X and the one item in Y, right? So it is going to pull one item from, okay, zip function is going to pull one item from each list, and it is going to assign one item into X and Y. That's true, Shruti. Yeah, that's true, right? Okay. Zip is from Python, right? Zip is from Python, not from NumPy. So once again, I'm repeating, zip is a function which is going to pull one item from list one and list two, and it is going to assign into X and Y, right? So this is going to run 10 lakh times, and every time the value of x and y is getting replaced. So what I'm doing with that x and y, I'm going to, add the values, right? So look at this expression. Okay, thanks. Is it okay? I'm sorry. Oh, zeros. You're bad. Okay, fine. Fine. Thank you very much, guys. I really appreciate your attention, right? And one more thing I want to say here, right? So when the participants are asking the question, in case if my other participant knows the answer, please type in the chat window. That will help me in, continuing with my content. Thank you, Shruti. Okay, so guys, I hope this expression is understood here. And whatever it is going to return in the form of list, square bracket represents list. Remember, square bracket represents list, and it is going to store it inside result, right? Okay. So guys, what we have done here, I extracted the item using the zip function. I extracted one item from list 1, assign into x, one item from list 2, assign into y. What happened with that x and y? What happened is that those x and y got added, right? And whatever the number was generated, like 0 and 0 plus 0, 0, 1 plus 1, 2. So it's like 0 comma 2, right? So that's why, yeah, it's a comprehension, you can say, right? So this is the beauty of Python also, right? That's how it works, like. And NumPy is more beautiful than this, right? I'm telling you, right? Just give me some more time to show you. So it is going to contain the addition of all the list, right? And now this is stop here, time dot time, okay, getting the current time after addition, right? I think this makes sense, isn't it? So we basically stored the start time, we did some math magic here, and then we pulled the current time in the stop. So what I'm going to do is I'm going to show you the difference. Print list took, comma, stop minus start into 1000. I think this should make sense, isn't it? Okay, am I missing any bracket? No, fine. So list took stop minus start into 1000 milliseconds. So that's how it works, right? So this should be understood by my participants, right? This time tracking, right? How I have done this. Thank you, Sneh. Now in the next phase, let's do time tracking for NumPy now. Okay, let's do time tracking for NumPy. So what I'm going to do is I'm going to start once again time dot take, right? And I'm going to add the arrays. So result equals to a1 plus a2. Now first of all, look at the beauty here. Okay, there is a beautiful guy there. Who is that? Okay, Manan Verma, thank you for that. Okay, so you can see the beauty of NumPy here, that you don't have to see go through all that complex stuff that was looking beautiful actually. And I'm going to time dot take, and just retrieving the time, and let's do a small copy paste here so that we can save some time here. And Python took, oops, NumPy took milliseconds, right? Okay, that's great. Fine. So let's see the magic here. Let's execute 1, 2, and 3. Oops, my mistake. All right, so here it's a hooping difference, right? Okay, it's a hooping difference. So we can see the huge difference in the time taken by the Python data structures and the time taken by what's that? The NumPy data structure, right? So it took, in my case, it took 230 milliseconds for adding two lists in Python, and if I do that with the NumPy array, it merely took 18 milliseconds, right? So it's really a huge difference, right? So Yes, MNBGTY, it can be used for more than two, right? So that's also possible. Fine. So guys, everyone, right? So did you observe the difference in performance and memory efficiency, right? So can I ask you, are you convinced with the efficiency of NumPy, guys? Okay, that's great. That's great. So, okay, that's great. Good, good. Cool speed. That's true. Yeah, true. That's cool speed. More than that, Rajesh. Yeah. Thank you, Elegani. Thank you. Okay. Fine. 369 versus third noble. That's crazy, isn't it? That's crazy. Okay. Just imagine when you're dealing with a lot of data, when you're dealing with a lot of huge sets of data sets. So in that case, it's going to bring some beautiful results and some you know something interesting. I recently went to a center, a government center where Aadhaar card was maintained. I found that their system scans through all the fingerprints within the milliseconds of time, and and later I found that they're using Python in conjunction with other programming languages and tools. So that was beautiful. That was a good experience there. Abhijit, no, there's not much differences. NumPy is basically, a particular module or library. It's not as brief and detailed about any other contents to be included. It's particular. Okay. So fine. Then let's proceed further. So in my okay, next topics, I'm going to discuss a lot of things here, right? So okay, generating random numbers in Python. Okay, guys. Now, because you have a good, because you have a good base now, so I'm going to, going to do it a little quick here. So I'm not going into details. Just see the code and learn the output, learn the response, and then proceed further. In case if you have a doubt, you can just point me. Otherwise, I'm going to move in a little quicker way here. Okay, fine. Generating random numbers in NumPy, right? So let's do that. Okay, printing. Okay, print np.random.ran 2 comma 2, right? Okay, fine. So here this is a function called rand, right? So what it does basically, it prints it generates an array. It generates an array of given dimension, and the numbers will be between 1 and 0. Okay, so it generates an array of given dimension, and the numbers will be between 1 and 0. You can see the numbers are between 1 and 0, right? And the dimension is 2 by 2, right? 2 rows and 2 columns, right? Yes, we can do that. So I'm going to show you, right, 2 rows and 6 columns, like that. Okay, so you can see that you can have, you have a number generator within the range between 1 and 0, right? Yes, we do have, right? I'm just going to answer you a lot of things here. Okay, so another one is np dot random dot choice. We have a, we have e, we have I. Oh, okay, guys, just keep a gaming sense in mind, right? Just keep a gaming sense in mind. Let's say you have a game where there are a lot of players playing around, and you need to, correlate those players with some sort of array or matrix. So that's how you can do it, right? Okay, so we have the choice here, right? Okay, so you can see here that every time I'm executing, I'm getting a different alphabet, mostly A and U, right? Okay, and this time I got E, and this time I got I. What I can do here is I can specify a size, and I can specify how many characters I want, right? Okay, so here basically what I've done is that out of this choice, out of this list, right? How many random alphabets are needed by me, right? So it's like that. Okay. So fine. Just have a gaming sense in mind, right? You're just creating some game and some random sense of some random sort of behavior you want. So out of a given set of characters, so you can simply have this thing in your mind. Okay, guys, I'll just proceed further. There are a lot of things to be done in random. I'm just going to into detail because this is sufficient to give you a strong knowledge. Excuse me. Sorry. Shape of array. Okay, fine. This reminds me of one of the Hollywood songs, I believe. Okay, shape of array we are talking about here. So what is shape of array? For that, I'm going to give you an example here. So here we have something about shape, which basically it tells you about the dimensionality of array, right, or NumPy array. Print a, so it is print a, and print a dot shape. So here you can see that it is 4 comma. Now, first of all, why this 4 comma is coming? Okay, so first of all, it's a 1D array or one dimensional array. Okay, now this is something that you need to take care. And what dot shape does, it returns number of elements in 1D array case only, right? So if it is 2D array, it is going to behave differently, but in 1D array, it is going to return the number of elements in the array. So how it behaves in a 2D array, let's see in this another demonstration. So this time I'm going to create one more array, np.array, and this time I'm going to create a 2D array. Okay, fine. And here we have 5, 6, 7, 8. So guys, now especially for the beginners, right? Especially for the beginners, this is a 2D array. Whenever I create a 2D array, creating 2D array, so you need to represent this thing like this, right? So how you visualize that part, right? So that's important here. So it's like 1, 2, 3, sweet, 2, 3, 4. 5, 6, 7, 8, right? So that's how you visualize, guys. Okay, so you need to visualize the array in this sense and make sure that you have the same you have the logic of rows and columns where the rows index starts from 0 and and the one column index also starts from 0, right? It's a matrix. That's true, Sujit. It's a matrix. So what is the shape of this array, right? Let's find out. Print b dot shape. What's the problem here? I did some mistake. Yes, I did a mistake here. And what's that mistake is? I forgot to add a square bracket here because it expects. Okay, good. No, it's not data type. By default, it's int 2. Leave it. Okay, fine. So it's so you can see here, guys, b dot shape. So how many rows and how many columns are there? So you can see here, there are 2 rows and 4 columns, isn't it? So when you see shape, it basically, doesn't count from 0, right? So it's a general counting, right? There are 2 rows and 4 columns. So I think now this shape makes sense, isn't it? So okay. So guys, did you understand that shape function is basically used to know the dimensionality of a given array object in NumPy? Is that clear, guys? Knowledge level here. Fine. So once again, I'm going to use this array object here, right? So once again, I'm using b.array. Yeah, KD can be multi-dimensional too. So here we have this array, and you can see here it is printing in the same way as I visualize it here. Okay. And now what I'm going to do is I'm going to show you the shape of B is comma B, the dot shape. So the shape of B is 2 comma 4. It is right, 2 rows and 4 columns, 1 2 3 4. So that's good. Yeah. Now what I'm going to do is I'm going to reshape the array, right? I'm going to reshape the array. Now this is something which is beautiful, right? Everyone now observe here, right? Okay, so what I'm going to do is I'm going to reshape it. B equals to B dot reshape. This time I'm going to make it you know okay, 4 comma 2, right? Okay, print B. Okay, print /n/n. So does this make sense, guys? Is it 4 comma 2, right? Just check after resizing. Is it 4 comma 2? Yeah, that's true. So you can see the beauty of NumPy here is that how easily you can simply change the structure. Print shape, and that is B dot shape once again. So here you can see that the shape of B initially was 2 rows and 4 columns, and here it is 4 rows and 2 columns after calling the reshape method here, right? So this is something which is beautiful about NumPy, right? So it's like that. So I hope this makes more sense now, right? How we reshape it. Apart from that, we have one more function, right? Flatten, right? Okay, so what does flatten does, right? For that, I'm going to give you an example here. B equals to B dot flatten. So as the name suggests, right? As the name says, it brings all the values in 1D order, right? So what do you mean by 1D order, right? Let's print after flattening. Yes, Asim, that's true. After flattening, the value of B looks like this. Okay, so what do you have here? We have all the values of that 2D array, or the 4 row 2 and 3 row 2. So it basically flats all the values and simply in the one dimension, right? So that's how you get it. So as I told you in the beginning of my session that it's all about array play today, how you're going to play with the array, and it's going to be more fun ahead, right? There's a huge fun waiting further. Vani, for 3D array, right? I'll just give you a hint here. Vani 3D array goes like this, right? 2 comma 3 comma 4, right? And then we have here 5 comma 6 comma 7. Okay. Okay, Vani, I hope this makes some sense, right? So I'm just giving you a hint here, right? I hope that helps. Sujit, what's the use of flattening? It depends. According to your requirement. Let's say you want your data to be in linear fashion, right? So if you want your data to be in linear fashion, you can use the flattening. So here we are not learning any question or any property or a method because of a reason, but we may require it or we might require it in further future while doing the data analytics or machine learning. That's why it's going like that, right? Okay, fine. Salai, it will not change. Hi, Josh, for you, it's a len function. Yes, Roshan, we can multiply. Soptic, I think you are missing the execution of your declaration of your B object or B variable, right? You are missing the execution of that. Yeah, Reshma and Shivani. Basically, it's number of items. That's true. I think Reshma was answering. Kumar Plotly is there. Yeah, sure, Bharti. In case if I get time, because I have a lot of things to cover, I'm definitely going to show you the demonstration for that. Shape returns tuple, that's true. Okay, moving further, right? Moving further. Okay, just a small test, guys, right? Okay, just a small test out of this NumPy array. I'm going to write some codes here, and I'm not going to execute. I just want your responses to be there on the chat screen, right? So let's get started. A equals to, and it's going to be quick, right? A equals to dot array, and I'm going to create 1, comma 2, comma 3, comma 4, comma 5. Okay, print type A, right? Just yeah, elegantly I'll do that. Just type the answers, right? Comma A2. Just verifying, right? Print A0. Okay, and okay, I'll do that. A0 equals to 5. Print A. Okay, guys, this will be fun if you can execute, right? Because whatever you're thinking of output is not there. Oh, that's good, Ravina, Snehal. That's good. Swamati, please check the code and observe, right? What is happening? Observe. So first of all, in order to, okay, I think you're asking about this one, right? So I'm just explaining this one. Rest should be okay. Yeah. So 1, 2, 3, 4, 5, 6. First of all, you need to learn exactly how you visualize the 2D array, right? So there are two lists here, one list and second list. So this is the first list and this is the second list. Now, basically, this position is basically 0, comma 0. Oops, I missed something. My insert is on. Okay. 1, 2, and 3. This portion is 0. Okay, this is called 0 row. Okay, this is called 0 row, and this is called 1 row. Okay, you need to observe this one. 0 row and 1 row. And this is 0 column, 1 column, 2 column. Once again, 0 column, 1 column, and 2 column. Okay, so from 0 row and 0 column. So this is 0 row and 0 column. So it is going to print 1. 0 row and 1 column, 0 row and 1 column, 2, 1 row and 0 column, 1 row and 0 column is this 4. So it's like 1, 2, and 4. Thank you, Katie. Thank you very much. I hope this makes sense, right? Thank you, Anthony. Thank you very much. Now it is going to be more complicated, guys. Everyone just buck up, just tighten your seat belts, and we are just moving forward with some more complex things here, right? So let's get started. Here we are talking about something called slicing, right? And slicing in 2D array, right? So this is going to be a little complex part. So I hope so everybody is ready for this. Now here I'm going to create an array here, np.array, and this time I'm going to create an array, right? In case if you can tell me the structure in chat window, it will be very good. 2, 3, 4, 5, 6. How it's gonna look like. Oopsie, 7, 8, 9. Let's make it more complicated. 4, 5, 6, 7, 8. Okay, I just made it more complicated, guys. 11. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Buddy, where are you? 9, 10, 11, and 12. Okay. Okay. I don't know what shape it is. Let's check it out. Oopsie, what happened, buddy? Did I miss some? Okay. Oh, come on. Every time I'm missing these brackets. Okay, got it. So it's 3 rows and 4 columns, right? Thank you, Shruti. Thank you. Okay, fine. That's great. So for the beginners, right, I'm just going to construct this array here for the visualization sake. So it's going to be 1, 2, 3, and 4, 5, 6, 7, and 8, 9, 10, 11, and 12. All right. So this is how this array is going to look like, right? Okay. Now, what we want basically, I want to extract. Okay, we are doing slicing here, right? So basically, slicing means that just retrieving the values out of this array. So how we are gonna retrieve the values from this array? Now here, the challenge is to retrieve the first row. Okay, the first row. Okay, when I say first row, can you tell me what row I'm talking about here? Okay, okay, fine. First index. Okay, fine. So, okay, now can I'm more clear now, right? So when I say index, that becomes a technical term. When I say first row, it is English. So when I say first index, that becomes technical, isn't it? So the first index row is, the one index row is this one, 5, 6, 7, 8. So the challenge here is to retrieve this whole row, right? We don't want any other data out of this matrix. So how are we going to do that? So this is something called slicing, right? So we have done this in string manipulations as well. So we're going to do this in an array, right? NumPy array. So let's do this. How are we going to do it, right? Okay. So first of all, okay, A, and specify the row and specify the column here. Okay, everyone. So specify the row and the column. Okay. Some people are trying. I want to, okay, from row 1, I want the first row and all the columns. Yeah, that's true. Oops. A10:4 Sakshi says, fine. Every person is trying. Okay. Why it's not working? I've done the right way, I believe. What is happening here? Am I missing something? Yes, I'm missing. I'm tangled in the questions, I believe. Okay. Fine. Sweta Kumari. Okay, 1:1:01. 1:2 KDI. You sure? Okay. Fine. So here you can see, guys, right? So how this syntax goes like? This syntax goes like A, row index, comma, star, means all columns. Okay, column index. Okay, it's like this. So in case if you're new to this, right, if you're facing trouble, so the syntax for this expression goes like this. A, the row index. So the row index is 1, right? And the column index, I want all the columns, right? So that is colon, like that. Colon is for all. So we can do the same thing in different sense, right? So for that, it's gonna be a little complicated this time also. Row 1 copy, right? And this time it's gonna be right. Okay, A, and I'm going to make 1:2, I believe. 1:2, and then I'm going to push a comma and then colon, I believe. Colon, and I'm going to print row underscore 1 underscore copy. Okay, fine. So fine. So guys, you can see here, right? So here, this is starting from 1 till 2 minus 1. That is 1 only, right? It's like, so the expression is like here. The expression is like 1 minus n minus 1. 1, 2. Okay, fine. So in case if this is complicated for you, right? You can see here, this expression is like from 1 row to n minus 1. So n is 2 here. So 2 minus 1, 1. So it's the one and the same thing, right? I'm just trying to show you the alternate way. It's an alternate way, but it's one and the same thing. It's an expression, right, Salai? That's the expression of how we do it. So guys, can I ask you for the third whole row? Can I ask you for the third whole row? So what you're going to write for the third row, 9, 10, 11, and 12? 2 comma colon 0 1 2 2 comma colon. That's true. Rajesh, Vaki, that's good. Yagna, that's going great. I'm very much sure that the participants who are doing the parallel programming are also doing the things. That's okay, Kenshu? Okay, fine. Now, fine. Okay, let's give it a challenge, right? Okay, let's give it a try. What if I want 2 6 10, right? What if I want 2 6 10? Print the second column, right? Or the first index column, 2 6 10. Okay, so the output would be like 2 6 and 10. Prabhu, that's because of the different shape as per your question data. So there. 2 6 10. That's good. So let's do it, guys. So let's print it. Print. What we have, a colon 1. Okay, so this works, right? So this is going good. That's great. That's great. Excellent, guys. Excellent. Another challenge. Pull 2 and 3. I'm encouraging my participants to do the parallel practicals so that they can, I want you to do exactly, right? So that is the ultimate strategy behind, asking the questions. Print a equals colon 2 1 colon 3. Okay, observe, guys, observe. Just giving you some time to, just go through this, observe what I've done.
Yeah, thank you, Rajan, for the informative session.
Yeah, thank you, Argo.
Yeah. So Rajan, as soon you send me the deck, so I can forward it to the learners.
Definitely, I'm going to send you in a moment.
Sure. Okay. Thank you everyone for joining today's session. And our next session is on Sunday at same time, 8 to 10. Till that time, we'll see you again. Thank you once again, Rajan, for your informative session.
Sure.
Yeah. Thank you.